Hey everyone, welcome to another edition of Ask an Astronomer, Earth Day edition. And we are here with our astronomer just a couple doors down from me and on ceded territory of Musqueam, Squamish, and Tsleil-Waututh. And that is Marley. Hey Marley, how's it going?
Hello, it's good. The sun's back. Please don't rain anymore for a little while.
Would be nice. It is nice to have the sun out. We've got lots of big events coming up, including Earth Day. We've got a full weekend of Earth Day activities. You know, Marley, there is a meme that goes around every once in a while. My friends send it to me, which kind of goes like some kids were in the planetarium and they were showing all of the planets. And when Earth came up, someone booed.
Yeah,
Uh,
I've had that happen.
Which is, it's always kind of odd from my perspective because Earth is the perfect planet in a sense, right? Like it is the planet that somehow, against all odds, life developed. And when we look at all of the planets in our solar system, when we look at all of the exoplanets that we've discovered, nothing seems to have all of the variables that Earth does, which ends up being, kind of that perfect piece. So we're going to delve into this special planet that some kids boo at in our planetarium, but it's going to end up being really fun. So if you're out there watching on YouTube land or on Facebook, maybe even Instagram, if I can get it to work, put a comment in and let us know any questions you may have about this presentation or any questions under the universe. We've got half an hour here. We will answer any and all of your questions. So, Marley, let's get going with some Earth visualization.
Sure, or Earth Day. So a big part of Earth Day that I think sometimes gets left out of the conversation because we really focus on, of course, the parts of the environment that we can touch, we can deal with it. Waste and garbage and composting and watching wildlife movement patterns and stuff. Things like that are very much things that we can get involved in as people. But one part I think gets lost are the Earth observation satellites themselves. Because if we're talking about climate change, right, that affects the entirety of the globe. And the easiest way to get a global view for something that happens all around the world will be through the use of Earth observation satellites. So things like rising temperatures and other effects of climate change we see at a global level. And in order to develop like next steps and next ideas for what we can do to help our planet, we need that information to track global trends and global changes over the years, and satellites are really the one things that we can do that with. And satellites can see a variety of stuff. We can really build the satellite for what we want it to do. So we can measure the changing global temperatures, sea levels, atmospheric gas composition is a big one, as well as ice levels and even forest coverage, and moving into imaging natural disasters in real time as well. And Canada is really involved in these types of satellites, especially because our country is so large, right? Like the three coasts that we have, as well as the variety of climatic zones inside of Canada, Arctic regions to the boreal forest to, the temperate rainforest like we have here in Vancouver, and, the plains in Saskatchewan and Manitoba and a bit in Alberta. All of those will have different effects from climate change on them. And so Canada as a country and the CSA as an agency is very involved in monitoring all the different impacts that can happen due to climate change. And so I wanted to kind of shout out one of those missions, and that is the SICAT mission. SICAT, that's it there on the right-hand side. It's a decently sized little satellite. But it is a partnership of universities, government, and industry. So it sits with all three. And it's been led by the University of Waterloo chemistry professor, Dr. Peter Bernath. He conducts the atmospheric chemistry experiments, the ACE on SciSat, which is one of the instruments on board. And that project specifically aims to measure and understand chemical processes that control the distribution of ozone in Earth's atmosphere, which is a really important molecule. Ozone helps to reflect ultraviolet rays out into space, so it protects the surface of Earth from those harmful rays from the sun. And so ozone is really, really important in terms of that, but also in terms of heat and monitoring what's going on in our world. SciSat launched in 2003, and it was only meant to last 2 years, and it's still active, like currently today. They've started decommissioning it, I think. I think the mission got extended until 2024, so sometime this year, it's going to start to ramp down and start to come down. But it orbits Earth 15 times a day at quite high at 650 kilometers above in a polar orbit, so it goes from pole to pole. or instead of kind of going around the Earth the other way. And it really has done quite a lot from its initial experimentation, which was focused on ozone, to moving to looking at overall atmospheric changes due to different chemicals that can cause greenhouse gas heating from them being in our atmosphere. Ozone itself is a very tricky molecule. It is constantly being created and destroyed by natural chemical processes in the atmosphere. And the amount of ozone present at any time will actually depend on the balance between how much is being created and how much is being destroyed. And out of all of the satellites up in Earth orbit, SICAT gives the most accurate measurements to date of the chemicals that affect ozone. And it measures an additional 70 different atmospheric gas traces to like the limit, like to the amount of parts per trillion. So instead of common terms of looking at pollution and chemicals inside of a solution is in parts per million or parts per billion. So 1 per million particles, 1 per billion. It can get to as specific as parts per trillion. So it's a very, very accurate satellite. This, oh, go ahead. Oh, no, he's not talking yet. The images here, this is like the ozone layer. So this was a big thing for some reason. Like when I was growing up, like I kept hearing about like the hole in the ozone layer. And I was like, I don't know what that is. I'm young. So
That was because of the hairspray.
yeah. No, it was CFCs, chlorofluorocarbons, as I learned when I was in grade 4. But this image is from NASA, and it's showing the size of the ozone hole over Antarctica and how it fluctuates year after year. But the trend is that it's getting bigger. Now, the good news is that it's actually started to shrink again after we eliminated the use of chlorofluorocarbons. I think it was like the Montreal Agreement, Montreal Summit in 1987. Like the whole world agreed, yeah, we're going to stop doing that because it was weakening the ozone layer and that would cause damage to the planet. And so how SICAT works is it measures the absorption of sunlight at sunrise and sunset as it sees it. So if it's orbiting Earth 15 times a day, it will see, sunrise and sunset 15 times. And so it looks at the atmosphere and how the atmosphere is absorbing the solar light, because each chemical, each element or molecule in the universe will absorb light a slightly different way. It's called a spectra. I couldn't find any spectras of ozone and other chemicals because they tend to be in the ultraviolet, so we can't see it. And so my sites could not help me with that one, but there's a little fingerprint for each one of them. And so looking at that fingerprint and the intensity and some other measurements of it can tell you how much pollutants are in the atmosphere. And SICAT was able to detect pollutants in the atmosphere that had never been detected from space before. One called HCFC 142b, which was is a refrigerant gas used to replace chlorofluorocarbons. It's weaker, but it still contributes to the greenhouse effect. And we wouldn't have known because no other satellite could detect it before SICAT. And so even though we found a replacement, there's still work we could do in terms of what that replacement does and how we could find maybe an even better one.
Very cool.
It was very cool. And it's like, when I say it's like global, like it really is. Like the data that has come from SICAT has been used by over like 1,400 different researchers. Over 300 research institutions across 20 different countries have used information from SICAT in their research and in their modeling for climate scenarios specifically pertaining to ozone. And once it kind of finished its mission for ozone, its main primary mission, it was still up in space. And so it moved to looking at other climate change, things that would impact climate change. And most of that comes from looking at aerosols injected into the stratosphere by things like bushfires. So it actually observed the aerosols that were released during the Australian bushfires in 2019, 2020, and saw that ozone broke down and was destroyed by different aerosols and specifically chlorine as well. We had never seen this before in space. We didn't have something that could look at it until SICAT took a look during these wildfires. And so that discovery helped to explain why the ozone depletion happened so much in the southern hemisphere after the fires, because there was a whole other chemical or whole other suite of aerosols and other elements that were destroying ozone that we did not know would happen before.
Yeah, certainly when I was growing up, that was the main focus of the environmental disaster, was the hole in the ozone layer and all the big focus. But then we stopped hearing about it because it came back. The ozone did sort of heal itself. So the Earth and the ozone for me has always been connected with, Earth health. But I've never actually heard ozone be referred to anywhere else in our solar system or even in some of the exoplanets. Is that something that we have detected anywhere else, or is an ozone layer specifically just for Earth?
I'm not sure if we've detected it specifically. So what ozone is it's three oxygen molecules together. Like it's a specific structure that you get with oxygen. And so I don't know off the top of my head if we've discovered it specifically in other exoplanet atmospheres. I know we've detected oxygen in other exoplanet atmospheres, but I don't know what form that is, if it's like molecular or atomic or as ozone. I'm sure there might be some because it can be created from natural processes that happen on a planet. It's
Okay.
just to what extent we would see it would change.
Okay, very cool. So we've got some improvements here with the ozone, this amazing little satellite. What else you got for us?
This kind of ties into, SciSat, now is coming out of commission probably in the next few years. And so what are we going to do afterwards, right? Like what have we learned and what can we contribute? And it all kind of affects us, but one that I think we feel here in Vancouver and BC at large, the effects of the most is we feel like the wildfire and the heat dome
Mm,
effect a
yeah.
lot from climate change, right? And so that is a really also big part of looking at and monitoring changes in terms of long-term impacts and long-term trends, but also natural disaster mitigation and helping with evacuation orders. So this is from NASA's Terra spacecraft. This is an image of British Columbia and a bit of Alberta and a bit of the States during the wildfires in 2017, which I remember being awful. The smoke from that was quite bad. I was working at a summer camp at the time, and we had to do camp inside because the
Mm.
smoke was so heavy we couldn't go outside safely. And so the Canadian Space Agency is in the process of developing a new satellite called WildfireSAT, and they're hoping to have it launching in 2029 with a 5-year mission. And true of most spacecraft and most space missions, a possible extension. We really do build them to last. And the purpose of WildfireSat is to support wildfire management, to give precise information on smoke and air quality conditions, as well as measure the carbon emitted by wildfires. Because when wildfires burn through, they are, burning down a lot of biomass, a lot of trees and things, and that will release carbon into the atmosphere. And so how much carbon is being released, how does that impact the upper atmosphere, as well as imaging air quality, smoke quality, and the movement of the fire itself, helping people on the ground fighting the fires and helping people to evacuate from those areas, as well as identifying like the quote unquote hot spots, like where could fires appear, where could we be worried about. And this will just be a continuing problem. As evidenced by the fact that there are already active fires happening. This
Mm.
is an image from NASA's interactive map. So I put the website down there. There's an interactive map you can go on. It's not necessarily continuously up to date, but it is pretty well done. And these are all different fires that are currently active, right? So there's a lot in northern Alberta, particularly. They're all quite small. Most of them are in the smaller 0 to 100 hectare range. But the fact that we never really came out of wildfire season, typically we would see with winter the wildfires would drop down, there wouldn't be much. The snow and the rain would help to extinguish quite a lot of them. That didn't really happen this year. It was a very dry year, El Nino year. It stayed very warm. And so we still have these fires that are not even under control. They're still out of control. And so wildfire season in the past years that I've lived in BC has started to come earlier and earlier and earlier. And so this will be an ongoing thing to manage and also to study to see what we can do to fix it. And that's what WildfireSat will hopefully do once it's launched in 2029. But in finding this map, I also found this really cool website that I really like, NASA Earth Observatory, which is an online publishing outlet. It has a tremendous amount of satellite imagery and scientific information designed to be shared with the general public. So if you want to look at a map of an area and look and see how natural disasters have or natural events have happened, water levels, snow and ice, different structures like that, you can go to this website and check out local maps and even global maps. Like they have whole areas, which I thought was very cool. Especially seeing the changes as they happen from year to year to year was very cool. There was a really interesting, I couldn't get it to play today, global fire map. Whoa, my whole computer just turned off and turned back on. uh a global fire map movie from 2000 until February 2024, so showing like where fires appear, and there is like seasonal trends to it as the earth moves around the sun, and the northern hemisphere encounters winter and the southern hemisphere encounters summer. You get this kind of flip-flopping of where the fires are, but they start to come earlier and earlier and earlier, and it's very harsh reality, but very interesting to see that like all laid out in a video like that. Is very cool. And I needed to put one more picture in as a shout out. Oh my goodness.
Is your computer still, is it
My
crashing?
computer's so upset. Yeah, it is. I don't even have that many tabs open. I don't know what I could have done.
Is it still going?
Yeah, oh yeah, it's black. I can hear you fine. I don't know. What picture do you see right now?
Well, it's just black.
Okay, yeah, that's because my computer screens are also black. But the image I wanted to share was of Calgary. Whoa.
You're still there.
You see me and everything?
Yeah, yeah, I see you and
Okay,
everything.
cool. I see black screens, so this is really fun. I see my mouse, and that's about it. But the image I wanted to show was of Calgary during the floods that we experienced in 2013, because there was a instrument attached to the International Space Station that is basically like a camera that was looking at Earth, and it captured the images of the flood as it happened, and you can see in like quite good detail the flood waters there, and then the flood and the sediment left over after the flood waters receded. And so it was a very interesting and very cool
Mm.
thing to look at. I can't do anything now, so I have to hand it over to Michael to finish it
It's all right.
because I can't.
We can still see you. You're not sharing a screen, so it's not it's just me and you on the screen now. So
Okay.
if you're out there on YouTube land and or Facebook, and I got the Instagram working, and I pushed everyone, I think maybe to YouTube. So if you're one of those people, and you have a question about any of the things that Marley talked about, our Earth observation satellites, and as a follow-up, if you want to come down, our head interpreter Matthew is going to be giving a presentation for our Earth Day event on Saturday, which is going to be a co-production with the Maritime Museum and the Museum of Vancouver. We're all doing Earth Day activities on Saturday, and then we're even doing hands-on workshops on the Sunday, and then the actual Earth Day is on the Monday. So, it's a 3-day holiday for Earth Day, even though it's not an actual holiday. But lots of fun stuff to talk about. So if you got a question about any of that stuff or anything else in the universe, throw it in there. So Marley, so with all of these Earth observing satellites, one of the things that I notice, when it comes to the conversation around the types of missions that NASA is doing, it seems like Earth observing kind of like gets lumped into all of these other exploration missions, and I'm wondering if that's healthy, because they seem to be like two very different things. Like one is about exploration, then there's also the human space exploration of the Artemis mission, but Earth observation is really, really tied to helping us understand our own planet. How do you feel sort of like around piecing out some of those things? Because of course they're all in space, but they do have like very, very different missions.
I guess for everything just came back, so I now have
Right.
control again. For me, I think the difference is that I think it's harder to make Earth observation exciting.
Mm.
Whereas it's
Hence the
always
kids booing in the
hence the
planetarium.
kids booing Earth in the planetarium. Yeah, yeah. It's a lot more difficult because you are dealing with topics that are upsetting, right? You are
Mm.
talking about the impact we've had on our world, and it's mostly negative. And so it's harder to make exciting than, say, looking at the wonders of a deep field image of hundreds of thousands of galaxies, like littered
Right.
across the screen. I think Earth observation science is a lot it's easier to tie into stuff, right? So with the International Space Station, yes, we're up there and we're testing, different technologies and microgravity environment, as well as, looking at radiation impacts and things like that. But there are a lot of external tests, like on the out on the exterior of the International Space Station, that are focused on looking at Earth. Things like the camera I was telling you about that I've now forgotten, iServe, I think is what it was called.
Hmm.
That was on there for 2013, 2020 until 2014, and it looked at the Earth and took images of it. And so those types of image capture systems end up trickling down to Earth rather quickly in terms of Earth observation. I just think their PR maybe needs some work, I think, at the end of the day. Because it is very cool to look at an image taken from space of your own planet and seeing like a volcanic eruption happening from space. Like, you
Right.
don't, I think people forget that the world beneath us is like an active breathing thing. Like,
Hmm.
the Earth goes through changes. The Earth is active, like geologically. The atmosphere changes. It's just change that we don't feel necessarily on the day to day. And so
Mm.
it's less, yeah, I think there's room for both. I think one is just much easier to get the general public excited about.
Well, it's really interesting that you said change because I think within that, it's very easy to see the changes of the Earth when we're doing it from space, as opposed to we're just walking outside of our door and we're kind of slowly, over a long period of time, seeing things change around us, even, like buildings popping up and even on our neighborhood here, things are changing. But, every day those changes aren't, they're not apparent to us unless we see them over sort of like a long period of time and can see those images. And perhaps that's where the existential dread kind of comes because maybe we don't like change, right? We like our Earth to kind of like be the same and not like come to that reality that yes, our planet is living and is changing beneath us, and we are having a large effect on it. And we need to kind of like come to grips with that. We'd be okay with the change, I suppose.
I guess so. Yeah. It's just, yeah, probably just people don't like change. That is very true. We as creatures love our little patterns and systems that we've established for ourselves. And as I've said, like about space, it doesn't care at all about what we think or what we enjoy. And I frankly think neither does the Earth, particularly does not care. The Earth will do what the Earth will do. And we have some say in that to an extent that,
Mhm.
we can certainly make things worse, but we can certainly make things better as well. So it's definitely a give and take, I think. But from space, like, I don't know, I love looking at pictures of Earth from space. I mean, the Earthrise image, is
Mhm.
a classic example. Everyone knows that photo of, Earth coming up behind the moon, from the astronauts around the moon, and like, or even the pale blue dot photo. Like, so that people do enjoy some way looking at Earth from space. I think it's looking at Earth from space in a more critical way that people don't particularly enjoy, and that's what maybe turns them off of it.
Yeah. And I think those images too from the International Space Station are, for me, some of the most powerful videos because that's something that we don't often get. When we're looking at space, often we get like static images, but those videos that we get from the International Space Station of the Earth moving underneath of us is, for me, is very, very powerful because it makes it more real. Like as if like you're in a plane and watching, the city move away from you, which is one of my favorite things to do when you're in a plane, is just to watch that place that is home kind of like slowly get smaller and smaller until it just vanishes. And now you're in a completely new place and you're seeing the landscape at large before you kind of get enveloped, within the city streets. And I find video very, 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 very powerful. Is there, uh, is there other kind of like Earth observation models that are using video in different ways?
Um, well, it's usually so when we are looking at like Earth observe. I'm hesitant to pull it up and share the screen because I'm worried my computer is gonna go all black again. But how they typically lay it out is they make it flat, right? So they don't have it round. And when they're modeling data, it is usually just colors getting like brighter and dimmer, like the
Hmm.
fire one I was talking about,
Yeah.
in certain areas. And so you don't see like the earth moving, you see the changes appear and then go and like kind of come away and disappear again. I don't know of any that use like the moving model. There's like Science on a Sphere, which is pretty cool. I've used some of their models in the planetarium before, but those are typically for like science centers and things like that. But you can like put data on top of a sphere and
Right.
see kind of what it looks like. But it's very, very hard, I think, to incorporate moving videos in the way you're describing into like scientific discussion.
Yeah, very, very cool. Well, if you want to get in and learn more about some of this stuff, like I said, Matthew, our head interpreter, is going to be doing a presentation here, and it's free of charge. You just come by. We've got some activities. Plus, if you want to see some cool shows all weekend. Plus, this evening, if you're out there and you're looking for something to do, we have an amazing event happening tonight that I'm going to have to go and run and start to get set up for, which is the language of the universe. Hooray, your computer's working again.
For now, let's wrap it up.
The Illusionist podcast, which is all about our language that we as humans use. They are taking over our planetarium. Marley's going to be downstairs in our auditorium talking about some really cool cosmic language that we use to describe things like spaghettification and quasars and blazars. So tickets are still available. You can buy them, I believe, probably at this point at the front desk before the event. And then, like I said, all weekend, we've got a whole bunch of Earth Day programming. You can go to our website, spacecenter.ca, to check that out. Plus, our next big event after that, May the 4th be with you. The 501 Legion are going to be back. Musician Thomas Beckman is going to be in our planetarium playing the viola, which is a really cool instrument that he's trying to like make popular again. Not many people play the viola, but he's going to play it solo inside of our planetarium. So that's going to be a really fun event, of course, on May the 4th. And that's going to wrap it up for this edition of Ask an Astronomer. Thank you so much, Marley, for your Earth observation. And if you want to join us again, we will be back live. I'm just looking up the calendar right now. May the 2nd, we are doing a whole science and science fiction month. So we're going to do Dune. We're going to do a whole bunch of our favorite ones. Send us some of your questions around science and science fiction. Of course, May and Matthew talked a little bit about that, the world on in
Yeti
Dune.
Prime, Yeti Prime.
80 Prime, yeah. If you want to talk about that, send us your questions. We will answer them all because we've got 3 Asking Astronomers in May. So we'll do whatever your heart desires. Send us those messages to the info@spacecenter.ca email, or you can message us on Facebook, Instagram. And that wraps it up again for this episode of Ask an Astronomer. We will see you all on May the 2nd. Take care, everyone.